Hello everyone, thank you for joining today's section on control systems. If this is your first time coming across my videos, my name is Daniel. I design, maintain, and secure controls and safety instrumented systems used in the oil and gas sector, chemical plants, petrochemical plants, and manufacturing plants. In terms of certifications and international standards, I'm a certified functional safety engineer, certified by TUV Renland to design and maintain safety instrumented systems strictly in accordance with the IEC 61511 functional safety standard for safety instrumented system in the process industry. I am also certified by the International Society of Automation as OT cybersecurity design specialist for the design and implementation of cybersecurity countermeasures to secure industrial automation and control systems, strictly in accordance with ISA and IEC 62443 OT cybersecurity standards. So this is a video where we continue with BPCS redundancy we started. This is part 2 of the series. First and foremost, I must put a disclaimer. The NAD, we call it network architecture diagram, you see on my screen here, is not a copy that I submitted to my client. This is a draft I just made this morning for illustration in this video, okay? So just for confidentiality, so I do not expose clients' documentation online. So that's just a disclaimer anyway. So today we'll be looking at redundant controllers, how to configure redundancy for basic process control systems. In this particular illustration, we are using Allen Bradley Automation's ControlLogix platform, which is one of the most powerful programmable logic controllers we use in many of oil and gas projects, as well as other industrial sectors. So I will quickly run through an overview, a quick overview of this network architecture diagram. Then I will quickly drop the information regarding the IP addressing when it comes to redundant controllers. So basically, if you look on the left here, you will see I've got rack 1 and 2 for the redundant controllers. So the modules, the one on the left is power supply module, then the one following it is the controller, then the next one is the redundancy module, then the communication module. So if you look here, one thing you will identify is, you will find out is that the system on the left, that's on rack 1, is a replica of the rack 2, that's the secondary. So we'll have the primary, we'll have the secondary. So it's going to be exact, we say part number as well as the firmware versions has to match in redundancy configuration. So going forward, the next one is, we've got 2 managed switches here, switch A and B. Then the rack tray here is for process area 1. Remember, this is just a draft for illustration in this video, okay? So the I/O signals from the process area 1 tied to rack tray. The same thing for rack 4, but that's for process area 2, I/O signals. So if you look below, you see control desk workstations. This is for illustration again, like I said earlier. So the thing is, you will see EWS, engineering workstation for configurations and engineering activities. You will also see redundant SCADA servers. You also see SCADA clients, historians. Even in most cases, you see jump servers for remote access. So this is just for illustration anyways. So let's go into the topic of today, assigning IP address when configuring redundancy. So we assign IP addresses on the Ethernet IP module itself. And if you look here, we've got 2 Ethernet IP modules. One is for the I/O network, what we call DLR network, DLR means device level ring. So it's a very robust network system. I will make a separate video for this. So, and the second one is for the SCADA or HMI communication, monitoring and control of the process. So what we normally do, that's what we call network segregation. So these two will not be on the same subnet. It's going to be on separate subnets, to segregate it. Anyway, I will do a separate video as well, and that will be under cyber security. Okay, so when you want to assign IP address, what we do is you assign, take for instance, 192.168.3, let's say .30. That same IP address you assigned for the, I'm talking of the IO, for the first one now, for the first Ethernet module, which is the IO network. So if you assign that IP address you assign there, that's still going to be the same IP address you will assign on the rack 2, the redundant rack controller. The same IP address. Same thing is applicable to the second Ethernet module, which is for the SCADA communications. So you put it on a separate network and assign IP address, and that same IP address you now assign to this particular one will still be the same you assign to the second that second Ethernet module on the second rack, on the redundant controller rack. So now that's an important thing you need to note. You will make space between the address. If you, for instance, if you used .30, you have to make available .31 for the redundancy switching. So you make available, make an allowance, leave an IP address in between. So what happens when there's need for the switch? This happens automatically. It happens automatically, but now when maybe there's a failure or something happens and the system needs to switch over from primary to the secondary, taking over. So what happens is that same IP address of the primary, the secondary is going to take it. When you put the system on run mode in the first place, the primary takes it, then that one you made available, the secondary takes it. But during the switching, the secondary now takes the primary IP, while the one after it you made available now moves to the previous primary, So that's how it works, okay? Benefit of redundancy system is brings high availability of the system, makes the system to be very robust. So reducing the downtime in your plant. So if you have systems that were poorly designed in the past or that are obsolete and you want us to optimize, reach out to me, reach out to our team. We will give you a robust design such that your control system will be optimized, downtime will be reduced, uptime will be increased, high availability, high reliability is what you will experience going forward. So reach out to us if you have need for optimizing your control systems. We'll make sure that your operations excellence is achieved. Thank you very much. See you on the next one. Bye. Cheers.